Hello everyone, myself Archana Priya. Today our topic is current electricity. Where current electricity, see this topic you feel really interesting because in our daily life we will be using so many electrical appliances, so you will really enjoy this topic. First let me go, what is electric current? So here you are going to study how does the charges will be moving and what are the characteristics of the current. Next, about the drift velocity, how does the drift velocity will be taken place and what is the formula. So we can solve few problems regarding the drift velocity too. And Ohm's law, here you can see the relationship between potential and current. Next, electrical resistance. So by using the Ohm's law we will be calculating the electrical resistance, on which factor it will be depending, and we will know few characteristics about the resistance. Next, electrical resistivity. So every material will be having its own resistivity. So we are going to study how does the current will be resisting in every material. So this is about the electric resistivity. VI characteristics. VI characteristics can also be called as Ohm's law characteristics. So which are the obeying the Ohm's law, where that characteristics you can study in this VI characteristics. And non-ohmic conductors which doesn't obey the Ohm's law, that is nothing but your non-ohmic conductors. Color code resistor, where color code resistors you have a different problems to solve it. So if the color code is given, we need to calculate few problems and it will be a very interesting thing and you will get a lot of fun in this. Next, electric current. So before starting the electric current, we know that all the basic particles is made up of the atom. So atom is made up of proton, neutron, electron. So the charged particle is nothing but it's a unit of a matter, where the fundamental unit just now I told, it's a proton, neutron, electron. A freely exists in the body, that is nothing but your charges. So the charges you can study neutrons which doesn't have the charge, where positron which is having a positive charge, where electron which is having negative charge. We are discussing about the current, the charge should be flowing, then only we can consider a current, because a rate of flow of charge will gives you a current. So the charge should be flowing. So none of the charge will be at rest, obviously. Now there is an important thing, instantaneous current. Like a rate of flow of charge is not steady, means if it is varying, if it is not steady, then it is called as an instantaneous current. We have a formula for it. So I is equals to delta Q by T. Just now I told that current is nothing but a rate of flow of charge. So the charge will be flowing in cross-sectional area, a unit cross-sectional area with respect to a unit time. Then it is said to be a current. I is defined, I is a symbol of current. Next, the SI unit of current is ampere. So we can know what is the SI unit of current, that is nothing but ampere. Ampere is a scientist name for that dedication for his memory we have kept as ampere. Small unit is microampere, where it is the smallest unit. This is a SI unit, international SI unit. So where this is about the everywhere we'll be using the ampere. The small unit is nothing but where current can be measured in the small terms also, that is nothing but a microampere 10 to the power of -6. Then even the current will be measured with a milliampere too, so milli value 10 to the power of -3. Next, dimensional formula for current is, we will be representing by the A, or even we can represent by I. So this is about the dimension formula of current. So next important thing, when we can say 1 ampere, when 1 coulomb of charge is flowing in a cross-sectional area in 1 second, per 1 second. So then I can say it as a 1 ampere. So 1 coulomb is nothing but 1 by 10 EMU. So by second. So SI unit of current is 1 ampere. We are coming for charge CGS unit. I can say 1 by 10 EMU. Now what will be the CGS unit of current? 1 by 10 EMU divided by second, that is nothing but 1 by 10 BI. BI is nothing called biot. This is the CGS unit of current. Next, the current is same in all cross-sectional area. If you consider a non-uniform cross-sectional area or uniform cross-sectional area, the current will flow uniformly in all direction. So, if you consider a small cross-sectional area where current can flow very faster, if you consider a large cross-sectional area where current can flow very slowly. This is about the current which is flowing in the cross-sectional area. Next characteristics, direction of current. So we know that what is the direction of current. See, in the charges you have a positive charge and negative charge. The current will be going along with the positive charge, along with the direction of positive charge. So the current direction will always be opposite to the electron. So always we should remember that. So positive charged particles, in which direction it will be moving? Your current also will be moving in the same direction. But now there is a confusion whether the current is a vector or scalar. When we are considering the direction of the current, obviously you feel that it's a vector, but it's not a true direction. So it fails to obey the parallelogram law in the vectors. So we will be saying the current as a scalar, or even we will say it's a tensor quantity, where you will be studying in your higher studies. Now you can see in this diagram, current I is flowing and current I2 is flowing and reaching at one point. That is nothing but you can take the total current as I is equals to I1 plus I2. Whatever the current is flowing, when it is reaching particular point, there your total current will be I is equals to I1 plus I2. Theta can be anything. Theta can be, it can give any value, but it gives you the I is equals to I1 plus I2. So I already said you the direction of current is nothing but which flows along with the positive charge. Next, charge is conserved. So charge will remain same at the both, even at the one end and the other end of the conductor. Now let me take an example. When we pass when we are connected with the battery to the conductor, initially the charges will be at the motion, but when we pass the battery, it gains more energy and still it starts flowing with the rapidly. But it can gain the energy and the velocity will be gained, but the charges will be remain same at the cross-sectional area at the both the ends. So the charge is conserved. Next, current different in different situations. Current will be different in different situations. So conductors, there you can see the motion of the electrons. Where coming for electrons, you can see the motion of the positive and negative ions. Where coming for semiconductors, you can see motion of electrons and holes, just similar to a human life. See, when we are in a classroom, we will be different. When we are in a house, we will behave very differently. With the friends, again with different behavior. So when we are humans, we are behaving differently in different situations. Even a current is also doing same thing. Where coming for conductors, the motion of the electrons, you can see it. Where semiconductors, you can see positive ions also, negative ions also. Where coming for semiconductors, there you can see the motion of electrons and holes. This is the property where the current, how it changes the different situations of the current. Next, types of current. So types of electric current, you have two types. One is a direct current, another is alternate current. Where direct current, it never changes its direction. It will be a unidirection. You can see the graph here, voltage versus time. That is moving in a straight line. There is no change in direction. Magnitude and the direction remains same. Where coming for an alternate current, it keeps on changing, it's flipping its direction. See, where you can see a graph over here. So here, from here to here, it completes one cycle. You can see half it is having a positive, half it is having a negative. Where you coming for an amplitude, it will be same. In a graph, amplitude remains same. Where coming for half cycle, it will be having positive, of cycle it will be having negative. Now we will discuss some problems regarding the electric current. Sir, Hello.